All right, so 1.5 is called quadratic equations. So last time we did quadratic equations, now we're going to do linear equations. So a quadratic equation is a degree 2 polynomial, right? That means I have a variable. Degree 2 means it's raised to the second power, right? So degree 2 polynomial of the form ax squared plus bx plus c equals 0, where a does not equal 0. Similar to linear equations, a cannot equal 0 because if a equals 0, then I would have a linear equation, right? So this is a quadratic equation. It's degree 2. I have x squared in there, right? So we've already done a bunch of factoring with quadratic equations. And so now we're going to do the same thing, right? So solving. So before we just factored, and now we're actually going to solve. So that means we're setting it equal to 0, right? So once we factor, we have the zero product principle. A times b equals 0. Then a equals 0 or b equals 0 or a and b equals 0, right? So that basically means we're going to factor. We're going to have the product of two things. The only way for the product of two things to be 0 is if one of them is 0, right? So this is something we already know. I think we all take for granted, right? We know that we factor and then we set each thing equal to 0, but this is why. The only way to multiply to 0 is if one thing equals 0. So that's why it's so important to get your quadratic equation to equal 0. Some people will leave a number over on the right-hand side. You got to get it equal to 0 so you can use this zero product property. So here's steps. First, we're going to rewrite the equation in the form ax squared plus bx plus c equals 0. Always has to equal 0. Then we're going to factor, which we did previously. Then we're going to use the zero product principle, which means set each factor equal to 0, and then solve. And then we can check our solutions. Okay? So let's solve for the variable. So number 1, we have x squared plus 9x equals 0. I have a quick question. What if I had y squared plus 9y equals 0? Doesn't matter what the variable is, as long as it's one variable, right, and you have it to the second power, then it's quadratic. So if I had y, if I had a, it doesn't matter. Okay, so I have it equals to 0. So step 1 is done. Now I'm going to factor. Can I factor this? Yes. How, Will? Take an x out, and I'm left with x times x plus 9 equals 0. Okay, so I factored. That's step 2. Step 3 says use the zero product principle. So I have something times something equals 0. That means I set each of those things equal to 0, right? So I get x equals 0 or x plus 9 equals 0. If I solve this, this is a linear equation now, right? If I solve this, I subtract 9 from both sides. And I get x equals negative 9. So my solution is x equals 0 or x equals negative 9. And you can go back in and check that, right?
Do I need to put them in the little
squigglies? You can. So Blair asked, do you need to put them in the little squigglies? So you can put them in like this. That's the set of 0 and negative 9. That means that those are my solutions. I usually leave it like this, but either is okay. All right, number 2, I have x squared equals 3x plus 10. All right, so go through and do step 1. Step 1 is get it equal to 0, right? Did I get it right? Mm-hmm. Okay, step 2, factor. Can you guys see in the back? I feel like a lot of you guys are squinting in the back today. Is it okay? You guys can move up too, if you want to. Okay, so I got it equals to 0. Now I need to factor. How am I factoring? I'm doing the AC method, right? What factors to negative 10 and adds to negative 3? So try to write that one down. So what factors of negative 10 add up to negative 3? What did you guys get? What did you get, Sylvia? Negative 5 and positive 2. Is that correct? Do these multiply to negative 10 and add to negative 3? Yep, so we're good. So we set each equal to 0. X minus 5 equals 0. X plus 2 equals 0. Then here I add 5 to both sides. I get x equals 5. Here I subtract 2 from both sides. I get x equals negative 2. Right? So you see how if you didn't get factoring, if you weren't comfortable with factoring before, it's really going to come back and get you, right? Because now we're doing this factoring thing twice. Okay, number 3, I have 15x squared minus 17x equals 4. First step is get it equal to 0. So I get 15x squared minus 17x minus 4 equals 0. If you need to go through and write down you're subtracting 4 from both sides, go ahead and write it. But you have to get it equals 0. Now what am I going to do? AC method, right? So I'm saying ax squared plus bx plus c equals 0, right? So I'm doing a times c. So 15 times negative 4 equals what? What is it? Negative 60. So I'm looking for factors of negative 60 that add to negative 17. So everybody try to get it. If you can't do it mentally, pull out your calculator. Does anybody get it? 12 and 5? Okay, so which one's negative, which one's positive, right? To be negative 60, one of them's negative, one of them's positive. Okay, so that multiplies to negative 60. Does that add to negative 17? No. Ryan has an idea.
Negative 20 and positive 3.
Negative 20 and positive 3. Okay, that multiplies to negative 60. Does that add to negative 17? Yes. So this is a good one because you have to go and check your work, right? Because there's a couple different ones that kind of add up. Okay, so how do I do the AC method again? What do I do? Now that I got this?
Split 17 into 23.
Good, so I split that negative 17. So I split this into this, right? Split that middle term up. And then what do I do?
Does it matter what way you put it in?
It doesn't. Did you put it the other way?
Or just wouldn't it make more sense to put it the other way because 20 and 4 go together and 15 and 3 go together?
I mean, you could. I mean, I can do it both ways, right?
Yeah.
We can do it both ways. Change the order. Right, it's the same equation. So now we're going to do factoring by grouping. So we're going to group the first. So I'll do both up here. And you guys could choose one on your paper if you want. So now, once I've done the AC method, I've split that middle term into two terms. Here I just change the order of the middle two terms, right? To do factoring by grouping. I factor the first two between 15x squared and 20x. What can I take out?
5x.
5x, and what am I left with? 3x minus 4 plus 3x minus 4 equals 0. So I just put this into parentheses so it's easier to see our common term that we can factor out. So here I'll factor out my 3x minus 4. And what I have left is 5x plus 1 equals 0. So maybe that makes more sense. And then I can do, if you did the opposite order, I can do that too, right? So what's common between 15x squared plus 3x? 3x. What's common between negative 20x minus 4? Negative 4. And I have 5x plus 1. So then between here, I have the common 5x plus 1. What I'm left with is 3x minus 4. So I got the same thing, right? So whatever works. If you saw it this way or if you saw it this way, the order doesn't matter. All that matters is that when you factor stuff out, you have the same term here. Once you have the same term here, then you can factor that out, right? Okay, so now now I've factored, right? I'm only at step 2 for this problem. So now I need to use the zero product principle. So I'm going to set each term equal to 0. Both of these are the same, so I'm just going to do one of them, right? So I get 3x minus 4 equals 0, and I have 5x plus 1 equals 0. So now again, I'm solving 2 separate linear equations, and I can do that just the way we did it before, right? Get everything without an x on one side, everything without an x on the other side, and then divide. So here I'll add 4 to both sides. And I get 3x equals 4. Then I divide both sides by 3, and I get x equals 4 over 3. Here, I'm going to subtract 1 from both sides, and I get 5x equals negative 1. Divide both sides by 5, and I get x equals negative 1 over 5. So those are my 2 solutions. Again, I could check these, but that's really, it's not as necessary. Checking is just to make sure your work is right, which I definitely recommend on exams. And if you're doing homework and you keep getting stuck, maybe check it, right? Just plug your answer back into the original equation. How are you guys feeling about this? I think everybody's typically pretty comfortable with this. So if you're not comfortable with it, you need to come to my office hours, okay? All right, how about everybody do number 4 on your own? Who wants to tell me the first step? Okay. So get it equal to 0, right? Okay. What did you guys do next? Next step is factor, right? Somebody tell me how. Walk me through it. AC method, okay. So what do I have? 2 times 9, which equals 18. Good? So let's check. 6 times 3 is 18. 6 plus 3 is not negative 9, right?
Both gotta be negative.
Both got to be negative. Good. So both negative, they still multiply to a positive, and then they add to -9. Okay, good. So everybody, keep going.
So you plug in the -6 and -3.
So tell me what to write, Suhei.
2x squared minus 6.
6x.
6x and minus 3x plus 9.
Okay, good. So we split that middle term up using the AC method. And now what are we doing? Grouping, right? So everybody do the grouping. Who wants to help? So from the first, you can take out the 2x, and then what do you have left?
X minus 3.
Uh-huh.
Take out minus 3. X minus 3.
So every time I'm writing equals 0, right? Don't get lazy. Uh-huh. Who else wants to help? So I need to factor out the x minus 3 first, right? And then I have 2x minus 3. Okay, now set them each equal to 0. X minus 3 equals 0. 2x minus 3 equals 0. So here I add 3 to both sides. I get x equals 3. Here I subtract 3 from both sides. Or I add 3 to both sides, sorry. And I get 2x equals 3. Divide both sides by 2, and I get 3 over 2.
How do we put the 2x in parentheses?
How come I put what?
The 2x in parentheses.
Here?
We put x minus 3 and we put 2x minus 3. How can we put 2x minus 3?
Here? So this is the x minus 3. And then here I have left 2x, and here I have left minus 3. No, you need to write this step. From here to here, you need to write that. Do you have a question, Charlie? No? What do you guys think? Good? Okay. Okay, so again, if you're stuck on this, you got to come to office hours. Because I'm getting a lot of, yeah, this is fine. Yeah, let's keep going. Okay? So now the next problem the next type of problem we're going to do is the square root property. So if u is an algebraic expression and u squared equals d, then u equals plus or minus square root of d, right? So basically for these problems, we can get something squared equals a number. So that typically means that our linear term, our x to the first power, is not there, right? As you can see in this example, I don't have the linear term. This example, I don't have the linear term. Number 7 is a little bit different, but that's typically what you're going to see. And this you can factor, right? How do you factor x squared minus 9? X minus 3, x plus 3. Good. That's the difference of squares, difference of perfect squares, which factors to conjugates, right? Talked about a while ago. But if you don't automatically see that, or if you want to solve this way, that's fine as well. So I want to get x squared equals numbers, or something squared equals something without the variable. So I get x squared equals 9. So what I'm going to do is if I ever have something squared, I take the square root of it, because by rules of exponents, the square root of the squared equals to the first power, right? So remember that x squared, the square root of that, right? The square root is the what power? What power is the square root? What? Half. Not squared, right? It's half. Right? And then by rules of exponents, you multiply these. 2 times 1/2 is 1. So that's why we take the square root, because it's rules of exponents, right? If we ever have something squared, to get rid of the squared, we take the square root because of rules of exponents. When I do that, I get x equals plus or minus 3, which, factoring, you get the same thing, right? So the most important thing to know is b, right? Because this is just a special case of b. B is solving by factoring, right? That's the most important thing to know. This is a special case of that. Okay? Now, number 6, I have 4x squared minus 20 equals 0. So I can add 20 to both sides. Now what? I could divide both sides by 4. And I get x squared equals 5, right? Now I've isolated the squared, and I can take the square root of both sides. What's the square root of 5? Something super ugly, right? It's just the square root of 5. So plus or minus the square root of 5. Okay.
So in the laptop, it won't make us put it like in decimals or anything?
It just depends on how it asks you. There should be a square root button, but sometimes it'll say rounded to the 3rd decimal place. So make sure you're reading, like underneath it where you type in the answer. Usually there could be a little something about rounded to the 3rd decimal place, you know. Okay, number 7, x plus 3 squared minus 16. So I'm going to isolate the squared again, because that's where my variable is. I'm isolating the squared. So I add 16 to both sides. So I'm going to start skipping writing the plus or minus each time and writing the divides each time. Are we at a place where we understand what that is? Okay. So if it's not clear, though, definitely ask. So I just added 16 to both sides, right? Okay, now I have something squared. That's when I can take the square root. So I get x plus 3 equals plus or minus the square root of 16 is what? 4. Okay? So then I'm going to subtract 3 from both sides. Okay, plus or minus 4 minus 3 is super ugly. Let's write it as 2 separate things now, right? So I have one is the positive 4, and the other is negative 4. Okay, so 4 minus 3 is 1. Negative 4 minus 3 is negative 7. So those are my solutions, right? So once you get the plus or minus, you might need to split it up in order to show exactly what your answer is, right? This is super silly if you leave this as an answer, because you can get numbers, right? Okay, so that is just a special case of factoring. Next, part D is the quadratic formula. I think there's like a bunch of little YouTube songs and stuff, right, for the quadratic formula? I'm sure. So again, we have ax squared plus bx plus c equals 0. Then we can use the quadratic formula. And the quadratic formula, you get 2 roots from it, right? X equals x sub 1 comma 2. That means I have 2 roots, just like I have here, and it's just a nice way to label them, right? I could write this x sub 1, I could write this x sub 2. So it's just a little notation to stay organized. But the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Let's say you're trying to factor something and you can't factor. you can always do the quadratic formula. Let's say you get to number 3 on this sheet or number 4 and you forget the AC method on a test, you can always do quadratic formula. Okay? So I said that part B, knowing how to factor, knowing these steps is more important than the square root property. I think the most important part of this section is the quadratic formula. Because the quadratic formula will help you solve a quadratic equation whether you can factor it or not. Okay? So whether you can factor it or not, so put some stars around this. I think most people know it, but this is the most important thing from this section. You guys all know the quadratic formula, right? If you don't know it, now you really need to know it, right? Okay? So let's do number 8. 5x squared plus x minus 2 equals 0. So again, the first step is I have to get it equal to 0, right? If it doesn't equal 0, I can't do the quadratic formula. Then the a is next to x squared, the b is next to x, and the c is the number by itself. Then you can plug it into the formula. Okay? So let's go to our problem here, and let's see what a is. A is what? 5. A is next to x squared. B is what? 1. B is next to x. And C, negative 2. Okay, once I know that, I'm just plugging it into this formula. So I can say x sub 1, 2, or if you just want to write x equals, some people don't like the sub notation. Negative b, so negative 1 plus or minus the square root of b squared. Make sure you're putting that b in parentheses. Minus 4 times a, which is 5, times c, which is negative 2. All over 2 times a, which is 2 times 5. Yes. So that's a good question. So Blair said she was told she needed to do it twice because of the plus or minus. We are doing it twice, but we're going to split it up at the end because the work is the same up until a certain point, right? Like even here, we were a little lazy. We put plus or minus, then we subtracted 3, right? And then we split it up. That's what we're going to do. If you want to do it 2 separate times, all these calculations underneath the square root are going to be the same, whether this is plus or whether this is minus. So I like to do it all together, and then once I simplify it as much as I can, then split it up. Okay, so 1 squared minus 4 times 5 times negative 2 is what? 41? Is that what you said?
I did.
Yeah, but then you're like, maybe. So I have negative 1 plus or minus the square root of 41 over 10. Okay? So that's as much as I can simplify it, right? The square root of 41 is prime, so I can't do anything with the square root of 41. That's just something ugly. So I get 2 answers from this, right? So I get negative 1 plus the square root of 41 over 10, or negative 1 minus the square root of 41 over 10. Those are both solutions, right? Another way you could see this answer is dividing both of these by 10, right? If I have addition and subtraction in the numerator, right? If we want to add fractions, we get a common denominator. So we could split up the numerator if we wanted to, and I've seen a lot of times solutions will be simplified using that algebraic property, right? So those are the answers. Okay, so let's talk a little bit more about the quadratic formula. Let's talk about the discriminant. The discriminant is the name of the stuff under the square root. So it's the b squared minus 4ac. That's the discriminant. Okay? That's it. So we're just looking at part of the quadratic formula. We're just looking at what's under the square root. So if what's under the square root is positive, right? Just like our example, we get two solutions. Graphically, if we're setting an equation equal to 0, we're looking for where our equation intersects the x-axis, right? Is that what we're doing? Anytime we set an equation equal to 0, we're looking at where our equation intersects the x-axis. So that means if I have a linear equation, 5x plus 12 equals 0, I'm looking for where my line intersects the x-axis, right? And that's because f of x, if I did function notation, equals y, right? So here I'm talking about function notation, which we haven't gone into yet. But I could write this as f of x equals, I'll just do the 5x squared plus x minus 2. If I set this equal to 0, or if I don't do the function notation, I have this equal to 0, that means f of x equals 0, right? Which means I'm saying y equals 0. Y equals 0 on the x-axis, right? So does anybody have an idea of how I can check my work on a calculator using this information? Right? How can we use this to benefit ourselves? Does anybody have an idea? Does anybody have a graphing calculator? Can I use yours, Will? I think mine. Someone else's. Okay, so if you have a graphing calculator, who has a graphing calculator? Okay. Do you guys who have a graphing calculator know this? Yes or no? Raise your hand if you know how. Come on, y'all. You guys are much more technologically advanced than I am.
Yeah, it's been like 4 years since I used a graphing calculator. So.
What are you asking?
How can I do this on my calculator? How can I solve a quadratic equation on my calculator?
Just plug in the thing and then see where it equals 0.
Yeah, you graph it and you say, where does this equal 0, right?
First the y equals, that's the one you do.
Yeah, somebody walked me through it, so, right? Press y equals. Walk me through it, Davis. I feel like you know. You're laughing at me like I'm old. What? Okay, so walk me through the steps. I don't care if you guys laugh at me. It's not going to hurt my feelings. Y equals right here. So that's how I graph stuff, right? Y equals. And then I could put in, let's do a nice one from the first test. Let's do y equals x squared plus 9x. That's number 1. We already know the answers are x equals 0 and x equals -9, right? Okay, so I'm going to graph it. Here's my x. X squared plus 9x, right? And then I hit the graph button. Okay? How do I know what those 2 points are, though? Emily says second trace. That's where all the good stuff is. Second trace, intersect. So I'm looking at where my quadratic equation intersects the x-axis, right? Is it intersect? Or is it 0? I think it's 0. I think intersect is where, if you want to know where two functions cross. So 0, so then it says left bound, right? So I'm going to go say, I'm not exactly sure what this one is, right? If it's a square root, it's some sort of a decimal, and it's ugly. So I'm going to go to the left bound, anywhere to the left of where you can see that it crosses, enter. Then I'm going to go to the right of it, enter, it says guess, enter, and it says my x is 0. So I just verified one of my points for example number 1, and then I can verify negative 9. So let me do it again. Second trace, that's where all the good stuff is. Go to 0, enter. Now I see this, it crosses the x-axis somewhere over here, so I'm going to go to the left of it. There it is, right? So anywhere to the left of where I see it cross, enter, right, anywhere to the right, guess, enter, x equals negative 9. That's what we got for the first one, right? So there's another way to check your answer, right? So again, the more you know, the easier things are, the more you can check your work, right? So again, underneath the discriminant will tell me if it's underneath the discriminant is positive, then I have 2 solutions. If underneath the discriminant equals 0, I have 1 solution, and why is that? Because if this discriminant equals 0 up here, I have negative b plus or minus 0. That's just, you're just going to end up with negative b, right, in the numerator. So that's why you have 1 solution. Okay? Here, if I have underneath the discriminant is negative, then I have no real solution, which means I get imaginary numbers, right? If you have a negative under the square root, that's an imaginary number, and we don't really deal with those in this class, right? So if you ever have underneath the radical in the quadratic equation, if your discriminant is 0, that means I have no solutions, and this is how the graph would look. It would not intersect the x-axis, right? Does that make sense? Yeah? Okay, so here we have determine the number of solutions. So I think you will have some homework questions that say determine the number of solutions. You don't need to go through and do the whole quadratic equation. You just need to look up the discriminant. So all we're going to do is we're going to look at b squared minus 4ac. So b squared minus 4ac to determine the number of solutions. If you want to go through and do the entire quadratic equation or factor or do all of that, that's fine. But if you know if the discriminant is negative, positive, or 0, then we can tell the number of solutions. Okay, so b squared minus 4ac. Again, I have ax squared plus bx plus c equals 0, and then I can plug it into the discriminant. So for number 9, what's a, what's b, what's c? 5, 1, and 2. So let's put it in 1 squared minus 4 times 5 times 2. Is that going to be a negative number, positive number, 0? If you're not sure, you can plug it into your calculator, right? I have 1 minus 40, right? So that equals negative 39, which is less than 0. That means I have no real solution. So determine the number of solutions. I have 0. Okay, number 10. Let's do it again. B squared minus 4ac. What's my A, what's my B, what's my C?
A is 1, B is 1, C is -6.
So Blair says the C is -6. How did you get that? Good, because I need to set this equal to 0 before I can really see what A, B, and C are. So I have b squared minus 4 times A times C. So I have 1 squared minus 4 times 1 times -6 is what? Positive 24, right? I have the negative. So I get 25, which is positive, so 2 solutions. So your graph will look something like this, right? It's a parabola. It could be pointing up. It could be pointing down. But it intersects the x-axis at 2 points, right? Number 10, again, I need to get it equal to 0 in order to determine the number of solutions. So what do you guys get? Somebody help Blair. I think Blair's done all of these ones. Last one. Number 10. Minus 3 squared.
Minus 4 times 1 times 9.
Which is?
I don't know if it's plus or minus, but it's 9.
So you're not sure about this one? How do you get? What do you guys think? Negative times negative is positive, but this shows why it's important whenever you're plugging a number into a formula to put it into parentheses. I'm plugging in b squared, which should be parentheses, right? If you put this in your calculator, it's going to come back with negative. So make sure whenever you're plugging a number into a formula, you put it in parentheses. So this is 9 minus what? Just what? Whatever it is, it's negative, right? So it's negative 27, which is less than 0, so 0 solutions. Okay? So we finished this section. We finished 1.5. So the homework I will make available and we'll make due either Monday or Tuesday next week, okay? Tuesday? Okay, so look at the homework over the weekend. Look at it before class on Monday so you guys can bring your questions to class, okay?
I have some questions.